And it's a second kind of introduction to differential equations. So that is the context of where we're going here, differential equations and kind of connecting them. So we've actually hit differential equations back on, I'm just going to refer back to real quick, page 299, I made a note. We actually already talked about what a differential equation is. It's literally just an equation with a derivative in it, and we solved them finding these particular solutions. So we've already kind of touched on it before. Okay, so a differential equation obviously involves a derivative. And this means we could be asked to do several tasks outside of solving the differential equation. Okay, so now some of those include, so we'll talk about solving them in the next few days, but here are other things we should be able to do with them. Write the equation of a tangent line. So I think we're pretty comfortable with that. Y minus y1 equals m times x minus x1. Use the tangent line to approximate a value. So after you write that, you find, I don't know, f of 2.1 or something. Take the second derivative, so able to derive another function. And then with that, a lot of times you'll do the second derivative test. Whoops. Second derivative test, which is old stuff we've talked about. And then finally check for critical values or relative extrema. So we're not going to actually solve them today. We're going to practice some of the other techniques we'll see that we'll be asked to use. So it says consider the differential equation here. So again, this is differential because it's an equation with a derivative. That's literally it. Let y equals f of x be the particular solution to the differential equation with this initial condition. Write an equation for a tangent line to the graph at 1, -4, and use it to approximate f of 1.3. So that's kind of tying in questions 1 and 2. So pretty simple question. They want you to write the equation of a tangent line. So you need an x, you need a y, and you need a slope. They're telling you at 1, -4, so they gave you the x, they gave you the y, and they really did give you the slope. You just have to figure it out yourself. dy dx is the slope, correct? So all I have to do is figure out the slope at 1, -4. So I'm going to substitute in a 1 and a -4, and I should get a slope of -1, I think. Okay, so anytime I see tangent line, I'm saying I need an x, a y, and a slope. And now let's just put it all together. So y minus y1, so y minus -4 is going to turn into a plus, equals -1 times x minus 1. So now that you wrote the line, it says use it to approximate f of 1.3. So all we're doing is plugging in 1.3 at this point. So y plus 4 equals -1 times 1.3 minus 1. 1.3 minus 1 is just 0.3. 0.3 times -1 is -0.3. And then I have to subtract over a 4. So I think we should get -4.3. So a lot of review today, so to speak. So pretty straightforward. Use the tangent line, approximate a value. Usually that will be like a part A or B of a differential equation question. Part B, now it says find the second derivative in terms of x and y. I want you to underline that. You have to have only x and y left in your equation. So I'm going to start with the first derivative. dy dx equals 4x over y. And they clearly want us to derive it. They want the second derivative. So when I derive this side, that's where the d squared y over dx squared comes in. Okay, now, as you recall, if it has x's and y's, that's implicit. So every time you derive y, you need a dy dx with it. And this is definitely a fraction, so we're going to go quotient rule. So I'm going to go low d high minus high d low. So the derivative of y, of course, is dy dx all over low squared. Okay, now, they told you that's not credit because it says it has to be in terms of x and y. I can't leave a dy dx in here. So I'm going to say this is equal to 4y minus 4x times, and in place of dy dx, I'm just going to put in what dy dx is. 4x over y all over y squared. Now, if it's not multiple choice, I'm probably not going to clean this up. This is going to be worth your full credit. If it's multiple choice, let's just kind of practice how we would clean this up. Okay, so I would say I have 4y minus 16x squared over y, all over y squared. I can multiply those numerators together. And then lastly, I really just don't want to leave a complex fraction. What could I multiply that would eliminate this fraction? Just a y. So I'm going to multiply this by y, and whatever I choose to multiply, I have to do it to every term. So everybody's going to get it times y. So my second derivative would be 4y squared minus 16x squared all over y cubed. Okay. But if it says in terms of x and y, make sure you replace that dy dx. Part C says, let y equals f of x be a particular solution to this differential equation. Does f have a relative min, max, or neither at x equals 1? Okay, so let's start with justifying. To say I have a min or a max, what has to first be true at that point? What does your slope have to be? 0. Excellent. You first have, this is called the second derivative test. Okay, two things have to happen. First, you have to establish that you have a slope of 0. If you do, then you can go on and talk about the concavity. If you don't, you know you're done. And second would be to look at concavity. Okay, so just a reminder, we haven't done the second derivative test in a while. So the first, you want to make sure you have a slope of 0. Second, you want to look at the concavity. So we're specifically talking at x equals 1. So what do we know about dy dx when x is 1? Think we've already found it, and typically that's how it goes. When x is 1, we know the y value is -4, and we know then dy dx, when we substituted 1, -4, and that's what we did up here, we got a slope of -1. Right? We already did all that up here. So what that's telling me is we don't have a slope of 0. So there is no min or max at 1. Okay, since we don't have a slope of 0, there's no min or max at 1. Now, if we did get a slope of 0, we would then plug our number into the second derivative, and that would tell us if we're concave up or concave down, and that would be whether we have a max or a min. Okay. So really kind of pulling everything we've talked about from those derivatives together here. So here's, on the next page, you'll find an example from the 2010 exam. It was question 6 on our AB exam, and we can do A, B, and C, it says. Consider the differential equation dy dx equals xy cubed. Let y equals f of x be a particular solution with f of 1 equals 2, so they're giving you a point. Write the equation of the tangent line. So let's put 30 seconds on the graph. Write the equation of the tangent line. We need an x, a y, and a slope. What do we get for the slope? 8 sounds good. So y minus 2 equals 8 times x minus 1. Piece of cake? Again, we're just plugging it into the slope. Part B, use that tangent line and approximate 1.1. Okay, so again, literally right off one of our old AP exams. This is the type of question you'll be asked to solve. Approximate 1.1. 1.1 minus 1 is 0.1, so what does that get me? A 0.8. And then add the 2. I'm getting y is approximately 2.8. And then part C, find the second derivative in terms of x and y. So again, start with the first. Christian, what rule are you going to use to take that derivative? Product is perfect. Excellent. So take a moment, use that product rule. Remember, it's implicit. There's y, so every y derivative you need a dy dx. And again, it said in terms of x and y only, so I can't leave dy dx in there. So I have d squared y dx squared. I'm just going to replace it. So I have 3xy squared times xy cubed plus y cubed. So I did first, derivative of the second, plus second, derivative of the first is a 1. And then I'm replacing that dy dx with this. Now again, you are more than welcome to clean it up. If it's short answer, you don't need to clean anything up. Okay, remember, it's timed, so we want to do, the quickest amount of work in that time. Don't worry about cleaning that up as long as it's all in terms of x and y. Now, obviously, you can. Obviously, when you multiply, add exponents. But you can clean it up. You just don't have to. All right. Go ahead and try example 3. Start with A and B. Let's get A and B. So I'll just talk through mine. Again, I got y minus 2 equals 0 times x minus 1. That totally wipes this side out. So I'm just going to solve for y since it's simple enough. I got y equals 2. Started with my quotient rule, low d high minus high d low over low squared. I can only have x and y, so I had to replace the dy dx with the x minus 1 over y. I noticed there was 2 of those, so I just called it x minus 1 squared over y. And then again, this is completely fine if it's short answer. But if it's multiple choice, just to be clear, I want to multiply everybody by y to eliminate this fraction. So I'm going to multiply every term by y. So I'm going to say it's y squared minus x minus 1 squared all over y cubed. Okay. So again, the moment I'm in terms of x and y, my answer is fine on short answer. But if it's multiple choice, I want to make sure I can clean this up by eliminating that fraction by multiplying everybody by y. All right, part C says, does your equation have a relative min, max, or neither at x equals 1? So again, we have to recognize that that is that second derivative test. Now, maybe you're thinking, how the heck am I going to recognize it? Well, if they ask you to take the second derivative, they're leading you towards the second derivative test, okay? So again, I need 2 things. To have a max or a min, I first have to see if I have a slope of 0. That's my first check. If I do, then I can look at the concavity. So when I had the point 1, 2, we already discovered that we did have a slope of 0 from the first part, right? So at 1, 2, dy dx equals 0. Okay, so right off the bat, I probably have a max or a min. Now I have to check the concavity. So I'm going to put check concavity. So I'm now going to plug my point into the second derivative. So my y is 2, so I'm going to have 2 squared and 1 minus 1 squared all over 2 cubed. So I'm plugging my 1 and my 2 into my second derivative. I'm using my cleaned up version here. The 2 squared becomes a 4. This 1 minus 1 just is a 0, all over 2 cubed, which is 8. And really, all I need to know is whether this number is positive or negative, and that will describe my concavity. So since this is greater than 0, that tells me I have a slope of 0 and I'm concave up. Okay, because the second derivative is positive, I'm concave up, and we had a slope of 0. Therefore, I have a relative min at x equals 1. Okay, so again, this is called the second derivative test. Use it if they're forcing you to take a second derivative. They're probably implying that's the second derivative test. All right, definitely want to squeeze another couple in here. Let's see what we can do here. Okay, now example 4. They love to just switch the letters on you, and you won't believe how many kids like literally go blank on this. It's the same question. Instead of calling it dy dx, they're using h and t. It's literally the same thing, right? This is like my y, this is like my x. So it says, write the tangent line at x or t equals -2. Okay, so the point they're using is -2, and did they give us the y? They did, -2, -1. And again, all I have to do is find the slope, dh dt, at -2, -1. Now again, this looks like my y, this is my x, so my t is my x value, so to speak. So this is -2 plus 1 all over -1 squared. Okay, so instead of x and y, they're using t and h. This is the t, this is the h. So the -2 plus 1 will get me a -1 over 1. I think I get a slope of -1. Now, the only thing is, when you put it together, you don't want to say y and x anymore, right? The variables are h and t, and yes, they will take a point off for that. So if you're thinking y minus y1 equals m times x minus x1, now let's put it into their variables. This is like my y, so this is h minus h1 equals m times t minus t1. We just want to make sure we're using the variables in the problem. So I'm going to say it's h minus -1 or h plus 1 equals -1 times t plus 2. Okay. You have to use the variables in the problem. Same equation of a line. Just make sure you're picking those variables. I'm going to skip find the second derivative. I think we've got that idea down. I'm going to flip the page on you here. Turn to page 325 there, example 6. All right, it says consider this differential equation. Again, an equation with a derivative. Let y equals f of x be a particular solution. Write the equation of, another tangent line. I think we got the tangent line down. Everyone feel comfortable with the tangent line? All right, jump to D. Describe all the points on the plane for which the slope equals -1. Okay, this is another question you won't believe how many people get wrong. So this is all for question 6 here. They're literally saying set dy dx equal to -1. All you have to do is take this function and set it equal to -1. Okay, it's literally what it says. Set your dy dx equal to -1. Now my gut kind of says like across multiply. I can put that over 1. So I'm going to say -2y equals x plus 2. And then just simply divide by -2. So I have y equals negative 1/2 x minus 1. Okay, so now what are they really asking us? Describe all the points for which the slope equals negative 1. What we would say is every point on the line y equals negative 1/2 minus 1, negative 1/2 x minus 1, has a slope of negative 1. Now there is one exception. I'm going to say except. All right, I want you to look at this equation. Because it's a fraction, at some point in time we have something that makes it undefined, right? And this is because we have a fraction. What can y not equal here? What makes it undefined? If we let y equal what number? 0. It would be undefined if y equals 0. Okay, so I'm going to have a slope of negative 1 at every point except when y equals 0. And that's strictly because that's when that function is undefined. Okay, now again, if that derivative didn't have a fraction in it, I wouldn't have an exception. It's only because there's a fraction in that derivative. All right, so quick little intro to some easy parts of differential equations. As far as homework from this goes, I don't want to worry about this today. Our homework is we have test corrections and a spiral. Okay, the test corrections come first. That's your homework tonight. Get them done. Spiral. And then we'll pick up with our differential equations again tomorrow, kind of modeling some solutions. Oh no, my book is falling apart.